In this case, we need to find the acceleration parallel to the plane. Now, in this case, we chose the force F to go upwards and the force X prime go downwards. As we know, the sum of all the forces is going to be the mass times g, which is 10, times sine of theta. We know that there's an angle theta right here below the object, and we know that opposite to the angle is going to be sine. Then we would just have to set up the equation. The sum of all the forces of x equals mass times acceleration x prime, this right here. Then we can cancel out the m's, but we would have to solve for this one. I mean, not solve for this one, we already know that it's gonna be m equals 2. So we plug in values, we do the rest, and we get negative 2.5 meters per second. It's gonna be negative because we chose the negative direction to be upwards and the positive downwards. Now in the second question, we need to find the force that will make the acceleration be equal to 0. So we just set up the equation. The sum of all the forces on the x direction is going to be equal to the mass of the acceleration of that same x direction. So we have to set up equal to 0. Now we just look at the graph right here. We know mg sine of theta is going to go downwards, minus 15 newtons is going to go upwards, and whichever the force, in this case that's what we need to find, is going to make the acceleration equal 0, which is right here. Then we just set up the values, and then we find that the force needed to make the acceleration be equal to 0 is going to be 5 newtons. So in this case, we got 15 newtons going upwards, and then 5 plus 10 meters per second. 5 plus 10 newtons equals 15. So 15 and 15 cancel out. That's why the acceleration is 0. First thing we want to do here is isolate both masses. In this case, we isolate mass 2 right here, and we know that mass 2 is going to be greater than mass 1 because of the tension going on right here. On mass 2, the acceleration goes downward because of the tension, and on mass 1, the tension is positive because the acceleration is going upwards. Then we find out these equations by doing the sum of all the forces on this mass and on this one. We also give a value for t, which is right here. Then, as we add up the two equations from the mass 1, we will end up solving for a. And as we plug in values, let's say we give a value for m2 and m1. These values, we just plug it in right here. Then we would end up having the acceleration being 8.18 meters per second. Now we do the same thing for the mass 2. But first we gotta find a value for t, which is this thing right here. So we know both forces in mass 1 and mass 2 are the same, 181.80 newtons, and same thing right here. Therefore, we will have the answers right here, A1, A2, T1, T2. And the mass 2,